So I'll take a few more minutes to introduce our speakers and we'll pass it on to get the presentation kick-started. So we have Stalin Rajkumar joining in from TechM. Stalin leads the digital process transformation practice and his portfolio covers BPM, HPC, low-code and integration. Stalin has over 25 years of IT experience and he's passionate about driving digitalization journey for his customers. And his major focus is to drive great customer experience. Welcome, Stalin. Join me in welcoming Terry and Nikita Ivanov from Gridkane. So Nikita Ivanov is a founder and CTO and he has got over 20 years of experience in building HPC and middleware platforms. He focuses on customer experience and business process improvement. And Terry has over 30 years of technology marketing experience in initiating and driving high revenue growth for multiple open source and SaaS companies. He's passionate about solving data needs of companies worldwide with open source products. Welcome, Nikita and Terry. Yeah, so I will leave it over to the speakers for them to get started. I hope you find this session interesting and informative. I'll pass it on to Stalin to give the introduction and the idea of this webinar. Over to you, Stalin.
Thanks, Kasturi. Thank you so much for the introductions and welcome again to everybody who has joined for this session. I hope you find it interesting and informative. And I'm sure that most of you must be joining this session from the safe confines of your home, thanks to COVID. But for a moment, let me take you a time when you had not probably heard about the word COVID. Let me take you back to 2019. Let me take you to the month of February. Sometime in the month of February, I think it was February 7th or so, you had a big outage for this bank called Wells Fargo. So all the systems were down, their online banking application was down, their mobile apps were down. So customers had a big problem. And Wells Fargo is the fourth largest bank in the United States. So you could imagine the number of users who would be using that application or using the online channels. So they had problems, right from transacting on the ATM, they could not withdraw money. They had problems doing online, payments. They had problems doing online shopping, and even the day-to-day business was affected. So that was the kind of impact, and it took a lot of hours for Wells Fargo to get it back. And by the time, there was a lot of chaos and all that with the customers. And then let me also take you back to the Black Friday sales, famously known in the United States for the Thanksgiving weekend, covering those 3 days. And we have seen time and again that many times the retailers online, channels are down exactly on the D-Day. Right on the D-Day, it goes down and it causes a lot of trouble. So in 2019, Costco's website was down on that Friday. And the estimates are that on that one single particular day, Costco lost about $11 million in revenue, because of the outage. Not only Costco, even the company called Nordstrom Rack, which is again another retailer, they also had an outage on in that particular day, and they also lost huge revenue as such. So the estimates of revenue, which people have lost is running into, millions and so on. And this was a time when it was, before COVID, when people could walk into the stores, and the online usage was probably less than what it is today. And even at that point of time, when there was no COVID, the sales for last year was a record sale from an online perspective. Last Black Friday sale was close to about $7.2 billion, which was a 14% increase from the previous year. And this was, remember, pre-COVID. And then COVID happened. And when COVID happened, people were pushed towards and people are getting pushed towards online. People are going to use more mobile. I'm sure in most of the people at your home, whether it's for work or for entertainment, for anything, most of the times you will find that people are in a digital medium. They are engaged with something which is digital. And this is going to be the trend in the coming months and the coming years as such. So it is, not only to one way you can say that digital is not only disrupted, it is going to change the way we are living in. I just took the example of retail just to highlight the impact of how much it can affect you. But this is the same with any other industry, whether it is banking, which we just now saw, or whether it is manufacturing, or whether it is logistics company, or even something like healthcare, where you have patient monitoring and information coming from multiple devices and so on. So the point which I'm trying to make is the effect of an application, the performance of an application is very much dependent on how many people are going to use, what is the volume of data which is going to come, and so on and so forth. So, I mean, no, it would not be, I mean, there's a lot of memes which is going in the internet, and one of the memes which is right now doing the rounds, in this COVID times, is the one which you see on the right-hand side, that, who led the digital transformation in your company. And if you look at the context today, if you look at the context which you're talking today, it is not the CEO or the CTO, it is COVID. Definitely, COVID is going to accelerate the digital transformation in your company. When the expectations on your online application being always be alive, able to process huge amounts of data, and all those things are happening, you need to have some technology which is going to enable you to make it available all the time online and process that volume. And if data is the new fuel which we're talking about, then accessibility, speed is what is going to make or break your business. So what kind of technologies are going to help us? So I'll move on to the next slide now. Yeah. So, so when you're talking about huge volumes of data, which is going to be aggregated from different sources, which has to be in scale, I mean, a scale which is unimaginable, like, for example, the Black Friday sale, where multiple hits are happening. And then you need to quickly process it in almost in real time so that you can get some insights, you can generate some decisions quickly, and ultimately delight the customer. So if there is some technology which is going to help you in doing that, in-memory computing is one of those technologies which is going to help your application performs, scale rapidly, handle huge amounts of data, and able to process it in a very quick time, real time, so that you're able to get those insights. Customers have realized this. Customers over the world are beginning to understand the importance of making their applications available all the time, and they have started investing in various technologies related to in-memory computing. And especially from retail industry, if you see a 1 second delay in page load time, it has got huge impact. I mean, the number of customers who will be dissatisfied because of just a mere 1 second delay is close to about 16%, and probably you will have fewer page views, and 88% of the customers would not even come back to your website if they have had a bad experience. So that is the kind of impact which a small delay in your website or in your application can have. And I mean, most of the reports are talking about how much investments is increasing in the in-memory computing space, and Gartner predicts that the in-memory computing space is going to touch close to about 15 billion by the year 2021. And Tech Mahindra is partnered with GridGain, who is one of the leaders in the in-memory computing space. And today's session is all about what is GridGain, how does it help in in-memory computing, what kind of solutions we have to offer, and how are you going to help you in making your customer experience or making your customers experience superior and high. So with that as the context and that as the background, I would like to request my partner colleagues Terry and Nikita to take us through the rest of the session in terms of what are the strengths of this product GridGain, how does it help, in what kind of industries and scenarios it can be used. And towards the end of the session, Jay, who's my colleague from Tech Mahindra, he will talk about what capabilities and service offerings we have in the in-memory computing space and what would we offer to you. So that is what I wanted to just share with you as a context, and I'll request Terry to take it forward from here.
Okay, thank you, Stalin. This is Terry Erzman. I'm head of marketing alliances for GridGain Systems. As you heard earlier, I'll take you through the first part of the presentation, then hand it off to Nikita to talk more about the technology of in-memory computing. But generally, what we see is digital transformation is really creating new demands for companies. And those typically take a couple of forms. One is the need for high performance from applications at internet scale. So business applications often must perform in real time, as Stalin just alluded to. Things like website performance is extremely important, and they must be massively scalable. So as COVID hits and e-commerce grows rapidly, you have to be able to scale out if you have a very popular website. But one of the challenges is the time and cost of re-architecting and building a new, better infrastructure can be a problem. At the same time, we see many companies, as they go through their digital transformation, that they want to do real-time, omni-channel customer engagement. So they want customers to have a seamless interaction across all touch points with the company. And to do that, the business processes need access to data across all the customer touch points, so you can create a 360-degree view of customers. But what we often see these days is cloud computing disperses data across separate and isolated data stores, and business applications and internal data stores are often data silos as well. So there's many data silos that have to be crossed. So GridGain, as an in-memory computing solution, solves two of these critical use cases. One is the challenges of application acceleration and scale out. So in those use cases, GridGain can be used as embedded software layer into existing software, business applications, or SaaS products. And in those use cases, what happens is GridGain serves as an in-memory computing layer, which caches the data in memory from across all the data stores that power the application, and can parallel process that data. So you get real-time speed. The data is already in memory. It runs, so it's immediately available. You're not waiting for disk, and you're parallel processing. So you get the power of an entire cluster of computers doing your processing rather than running on a single server. And because that is a distributed computing solution, so it's run on a cluster of computers, it's massively scalable. You can add more nodes to your cluster to increase the amount of RAM and the amount of computing power in your in-memory computing cluster. So as your application grows, as your users grow, you can just scale out and grow right with them. The second critical use case where we typically see very good uses for in-memory computing are what is termed a digital integration hub. So in those use cases, what we have is we're aggregating multiple back-end data sources, and we're providing one or many applications with high-performance data access to that data from all those different data sources, which may be siloed. In those use cases, the fact that GridGain offers a unified API also helps future-proof the architecture. So it's very easy to add additional data sources in the future. It's easy to add additional applications to that high-performance data access layer in the future as well. So this architecture can grow with you and can expand as your business needs expand. So talking about that first use case, the application acceleration scale out. As I mentioned, this can power internet scale applications because of that data caching and because of the parallel processing. And it provides that massive scalability because of the distributed computing nature. It easily integrates with existing systems. So again, GridGain is deployed as an in-memory computing layer, which sits between an existing data layer and an existing application layer. So there's no rip and replace of the existing databases or applications. This isn't re-architecting and rebuilding your application from scratch. This slides in between what you've got currently, but speeds it up and allows you to scale it out very easily. Data is easily accessed via that unified API I talked about. So depending on what your data layer looks like and what your application looks like, it's easy to integrate that into the stack. It does support SQL. So if you're used to using SQL with your transactional relational database, you'll be talking to GridGain. You can use SQL to speak to GridGain as well, and makes it very easy to integrate into your stack. Works with all popular relational databases, NoSQL and Hadoop data stores. So it doesn't matter what data layer or what data base you're using underneath your application right now, GridGain can handle that. It can slide in and integrate, speed up and scale out your application. And all of this is built on open source Apache Ignite. So GridGain was a company that contributed the code that became Apache Ignite to the Apache Software Foundation. So beyond the users of GridGain, there are thousands and thousands of people using Apache Ignite in production applications, and all those folks are helping to make that product better, and that by in a typical open source model helps make our products better, the GridGain products. So a couple of examples of this application acceleration and scale out that I just described. One great example is Sberbank, which is a top 20 worldwide bank, the top bank in Russia and Eastern Europe, and has more than 16,000 branch locations and 135 million customers. So the challenge they faced when they first engaged with us was they were introducing mobile banking. And by introducing mobile banking, they knew that they would see about a 100x increase in load. So they're going from tens of transactions per second to hundreds and hundreds of transactions per second very, very quickly as they turned on mobile banking. They knew that their systems couldn't scale to handle that within their core banking applications. They also lacked a common storage layer across the bank, so that ability to share information between business units and between data stores. And they had very high cost relational database infrastructure, so they were paying a lot of money for those relational databases that their applications were built on. What they have done is they have integrated GridGain into their infrastructure across many of their business units at this point. And what it's created is a common data foundation for their core banking systems, and it's expanded into other processes. So it drives many of their business applications from credit card processing to core banking. And what they've done is they've horizontally scaled across thousands of servers in 3 data centers with 1.5 petabytes of data in memory. So they have many different GridGain clusters running that can all talk to each other and that all power different business applications. And they have 4 nines availability with their immediate restart from disk. So they use the persistent store feature within GridGain. They've moved to the next level of in-memory computing, where there's no need for memory warm-up in case of a restart for extra availability to make sure that their applications never go down. If they ever have some interruption in their GridGain system, they can rapidly restart it and get back to that high performance, high customer experience that they were driving for. Another example is American Airlines. So in that case, they are using GridGain for their route planning tool. So American Airlines is the world's largest airline by fleet size, passengers, passenger miles, and number of destinations. So they're a very, very large transportation company. And they had a couple of challenges that they wanted to address. So one was difficulty in accommodating passenger needs when they had tight connection situations. And one of their challenges is if there's a single change in a flight status for a single flight within their network, they need to recalculate their entire network routing plan to make sure that they now take in those changes into account and make sure that everybody can still make their connections and that all the baggage gets to where it's supposed to go, and make sure their system runs seamlessly. They also had a challenge with price optimization, which wasn't really possible before they implemented this, and that led to less efficient, more costly travel plan changes. So they really wanted to attack those 2 challenges. What they were able to do is get a real-time view of all passengers with connections under 45 minutes to facilitate their baggage transfer and rebooking. So greatly increase the customer experience. And they were able to analyze flight plans and run price calculations to offer optimal pricing across that, and minimize their costs as well as offer best prices to their customers in case anything changed. What they have created is a horizontally scalable multi-data center architecture that is more cloud native. So they use Docker and Kubernetes to deploy this. American Airlines actually presented this, the work they were doing at the In-Memory Computing Summit, which is a annual in-memory computing conference that GridGain organizes a couple of years ago. So if you're interested in learning more about their specific use case, this is available online to hear it directly from American Airlines. That second use case I talked about, digital integration hubs. So again, this is really about providing performance, scalability, and real-time data access across many data stores and across many applications. And in these use cases, GridGain functions as this high-performance data access layer, and it loads data from any connected cloud or on-premise database or data stream. So it can be existing SaaS application, it can be internal transactional or operational data stores, it could be streaming data, things like stock quotes, for example, or weather patterns. All that data comes into GridGain, and it's in that one high-performance data access layer where the applications can now access that data, even though that data may be siloed in many different places across, across your architecture and outside of your architecture in terms of your cloud computing sources. And it enables that real-time data access from a single source for any application. So in this architecture, your applications just talk to GridGain. All the data is there. GridGain takes care of syncing any data changes back down to the data sources, as it does in the previous example. And your applications now don't have to bang on these on your cloud SaaS applications. GridGain can access the data there, pull it in to that in-memory computing layer, and your applications can just talk to GridGain, which you can scale out and make as fast and as scalable as you'd like. And this is, again, scalable with petabytes of data, so you can have a massive amounts of data residing in your GridGain data integration hub layer. A good example of this is 24-hour fitness. So again, this was something they presented at the In-Memory Computing Summit, and they talk about their use case directly. But 24-hour fitness is a US-based fitness center chain. Prior to COVID, they're going through some challenges with COVID, as you might imagine, but they had 400 plus locations, 4 million members nationwide. So they had a few challenges, and it was really around customer experience where they were really struggling. So one of the challenges they had is their third-party systems had API limitations, they had differences, they had complexities, and when their applications were trying to speak directly to those third-party systems, for example, and the one they really were focusing on initially was their SaaS billing system. They couldn't do everything they needed to do, and what happened is because of the limitations, even in the number of API calls, for example, they had a situation where their data was frequently out of date and never in sync. So what happened was check-in time skyrocketed. There were many issues with duplicate payments because people would make payments. It wouldn't be updated in the 24-hour fitness applications quickly enough, even though the payment had been made in the SaaS billing system. And they were spending a lot of extra time reversing these duplicate payments, and customers were very unhappy because of the challenges with check-in times where people go to check in, look like they hadn't paid their fees. They'd pay again, they'd be stuck at the check-in desk. It caused a lot of chaos. So what they did in this case is install GridGain as this high-performance data access layer, and they took the data from the third-party data stores and now just made it available in GridGain through a unified API. And in that case, what they were able to do is make real-time customer membership and billing visible across all their internal and external systems. So if someone was checking in, they had real-time access, real-time data access. They could see exactly what the situation actually was, so people could check in quickly, increase customer satisfaction. And then also they were able to create upsell opportunities, power not only those decreased check-in times, but also a better experience for customers, no matter how they were interacting with them, whether it was the check-in desk, whether it was online, whether it's through their mobile app, it didn't matter. They had a high performance data access layer. That billing information was real time, and they could then tie in other systems into that GridGain digital integration hub layer. So major brands use GridGain. We sell to companies worldwide. In-memory computing originally was largely focused on financial services a decade and more ago. Those were companies where time was really money back then, and it was expensive to implement in-memory computing technologies. That's really changed over the last 5 to 10 years. So especially over the last 5 years, we've seen massive growth outside of financial services. We still have many financial services companies, and we continue to grow within that market segment. But now we see, transportation, logistics, e-commerce and retail, telecom and mobile, software and cloud applications, all implementing in-memory computing technologies to speed up and scale out their applications, or to create these digital integration hub layers, which allow them to drive these 360-degree views of customers for a better customer experience across their business. As I mentioned, GridGain is built on Apache Ignite. Apache Ignite's a very popular project. It's had more than 15 million downloads and Docker pulls at this point, and it is one of the most active Apache software foundation projects, with uses by many companies who are not currently GridGain customers, but we do know that they're using Apache Ignite because we do interact with them and hear from them, and do see them active in the developer lists and the user lists for the Apache Ignite community. Okay, with that, I will turn it over to Nikita, who will talk more about the GridGain platform and exactly how it functions. Nikita?
Thank you, Terry. GridGain platform is literally about two things. It's a speed and scale. And you gain speed by moving data from disk to RAM. And that's the basic essence of, for the last literally 30, 40 years of what in-memory computing is all about. You're trying to move data away from a slower medium, such as spinning disk or tapes back in those days, and from flash today to RAM. RAM was dramatically faster and much closer to processing, and therefore allows you to really gain that speed. But it's also about scale, and that's something a lot of people don't realize initially. The scale comes from a massive parallelization of processing. And we don't have time today for kind of historical background, but just a few words about it. The scale or parallelization is not really intuitively attached to in-memory computing. I often get asked when I present about it, why are we talking about scalability when you guys talk about in-memory? And back in the late 90s, when in-memory computing started to kind of grow up out of the specialized one-off projects, the computers didn't have much RAM, and therefore, in order to really have something useful with in-memory computing, you have to string together many computers into the clusters, into the network. And from those early days of developing memory computing, and memory computing systems becoming one of the most complex and most advanced distributed systems in existence, and that continues today. GridGain has, performed tests over several thousands of nodes in topology for massive scalability. On the functional level, like you see on the slide, you can literally divide functionally, or logically rather, divide a functionality of GridGain into kind of major areas. Some of the core in-memory data processing facilities, which includes in-memory data grid and in-memory databases, they're very much the same, but you really get into the with the GridGain, if you're familiar with SQL databases, you can, look at and use GridGain as a SQL database. We supply a full SQL 99 capabilities, and you can augment or replace your existing, SQL stores. We also given you a more specialized, version of a storage called in-memory data grid that allows you to gain a significant performance capabilities over the existing SQL databases. Combination of both two really provides you a core capabilities on your platform. And another kind of aspect of what GridGain does is what we call memory data analytics, data analysis features. And we continuously growing that part of our product. And today we have a streaming analytics through integration with Kafka. We have a homegrown continuous ML and AI modules. We've implemented many statistical machine learning algorithms on top of the grid gain so they can take advantage of the parallelization memory storage. And we also provide you a out-of-the-box, practically industry-first integration with TensorFlow. So if you're in the deep learning, you can really use grid gain as your data source. To the next slide. So Terry mentioned we're truly a leading in memory computing platform, and it sounds like a marketing speak, but it's not. I started working personally on memory computing in the late 90s, and I started this project almost 15 years ago. And we are today essentially a leading Apache Software Foundation project for memory. And Apache Software Foundation, I'm talking about Ignite, which is the foundation of grid gain. It's the same foundation that spun up, Hadoop and Kafka and Spark, and we're in exactly the same family of projects. And it's truly a leading platform today. It's a complete platform. That's very important. And we're not just, a piecemeal of some implementations. We provide you both analytical processing and transactional. We have fully ACID transactions support, SQL NC99, as I mentioned before. Unlike many other projects, and I think Terry mentioned this too, we don't really require rip and replace. And that might not sound like a big deal right now, but I always keep saying, go back to your organization and try ask him to replace database and see the reaction. And 9 out of 10 time reaction will be no way. We can't replace database. And that's actually very important capability of Ignite and grid gain platform, is that we don't really require you to replace it. You can, partially or fully, if you like it, but you always can start without replacing anything. You slide in between data layers and application layers, and we provide you this all scalability and performance without asking you to replace your existing databases. And that's a very, very important fact, because once again, it's very hard to rip and replace existing data stores. And we also provide you integrations, with a lot of what I call AAA projects in open source community, whether it's a Kafka or Spark or TensorFlow. We work beautifully together through native integrations. The next slide, Terry. From a deployment standpoint, we're what I would call the first-class citizens. In today's ecosystem of clouds and deployments, we either certified or work natively with pretty much all the major cloud providers, from AWS to Microsoft Azure. We certify on Oracle Cloud and Google Cloud. We're available in the marketplaces. We also basically part of the several very important foundations. We are obviously part of Apache Software Foundation. That's where our a core project, Apache Ignite, is hosted. We are also part of a CNCF Cloud Native Computing Foundation, and we're also working with Linux Foundation on several initiatives related to Kubernetes. And we also have a fully Dockerized, so all the major deployment models and tooling today, we're fully supportive, including Docker and Kubernetes for sure. I think it's a summary slide for me, but just to very briefly, so it's really hard to talk technically about this, fairly widespread product, but try to keep it very simple. Again, just a few things to remember is that in memory computing was really about 2 things, as I mentioned in the very beginning. It's about speed and scale. It's very important, because if you only get speed but not scale, you're not getting far. If you don't get speed but scale, again, you're not getting far. Case in point, like, for example, products like Cassandra that give you scale but don't give you speed. In memory computing platforms, specifically grid gain, really gives you both. As I mentioned, you get speed by moving as much data as possible from slow, medium to RAM, which is much faster. And you get scale by distributing this processing and parallelizing this processing. So grid gain really gives you both a memory data grid and memory SQL databases. Those are 2 different paradigms how you store data. the in-memory SQL database, something that you're all familiar, probably at least heard of it. In-memory data grid, something a little bit different, but does give you tremendous performance increase if you need it. We support both SQL, classic NC99 SQL and NSA transactions. We provide you the integration for the machine learning, both by implementing the statistical machine learning algorithms on our platform and by providing the integration with the TensorFlow, the leading deep learning neural network engine. And we probably one of the most important things beyond technicalities, we're building Apache Software Foundation project. We're building Apache Ignite, which is, as Terry mentioned, is one of the top 5 projects in Apache ecosystem. That's a pretty big deal, by the way, because Apache Software Foundation has about 350 projects. And to be one of the 5 in the same category of Kafka and Spark and Hadoop is a big deal for us, and it's a big deal for community. Terry, I think it's back to you.
Yes, thanks, Nikita. So just to quickly sum up, and I'll turn it over to Jay. As Nikita mentioned, and as I talked about, we really address 2 critical challenges: application acceleration and digital integration hubs, used by leading companies worldwide, as I showed on the slide. Many of those companies have spoken at the In-Memory Computing Summit. If you're interested in learning more, you can visit that In-Memory Computing, imcsummit.org, and see their presentations. And as Nikita just mentioned, we are built on Apache Ignite. And with that, I will turn it over to Jay.
Yeah. Thanks, Jay. Hi, everyone. This is Jay Narayan. Good morning, good afternoon, good evening to all. So I'm a solution architect, and I had exposure and had an opportunity in involving dealing with the high performance computing in various assignments of integration for enterprise apps. And I would like to share, based on recent trends and what we could see on performance, which really matters, as Stalin and everybody were articulating on the data intensive application, and more users are going through digital, and the volume of data what we deal with a decade before or even 5 years before is exponentially increasing year on year. So it is not just app development or dealing with any kind of traditional DB related apps or having big data Hadoop system. It's more important how we scale it in speed and how quick the data we are going to handle, the massive data, in terms of analyzing, which is used for data analytics or real-time monitoring, streaming analytics, so various use cases. So this IMC technology is very, very helpful, and we could able to leverage this and use it in many of the performance bottleneck which we see across enterprise apps is being accomplished with IMC to certain extent, at least 41%. That's what we could see in our experience in integration. And so this particular graph shows, okay, in a performance computing, what traditionally enterprise faces and what are the issues what percentage of the issues is going around. If you see, most of them related to the storage. And if traditionally, if you do a performance analysis for any enterprise app, if you see, they are very highly distributed enterprise apps, having evolving, changing application architecture, facilitating mobile devices, third-party services. So solution as a service, if you see many enterprises going for a SaaS products, rather reinventing inside for speed to market. And in all those challenging situations, the data intensive and then in order to scale better and due to the hybrid paradigm where they have multiple apps in different hosting environments, the potential performance become a nightmare, or even you say like it's very much required for any of the applications. It's customer facing or business facing, considering the trend how the volume is going to increase. So this IMC technology is really helpful When you say in olden days, like when we move, there are two things which core intensive performance hidden in before. We used to have moving the data from memory and then do a compute on a separate compute engine. This compute engine doing computation takes more time in digital fashion and quite expensive and power consumption. But in terms of IMC, where both moving data from memory and computation in itself could be dramatically improved by moving operation directly into the in-memory, and these IMC technologies are very good at it in accelerating that, and which we could see predominantly in recent trends in the enterprise. So when we do the assessment, for example, as a Tech Mahindra has very extensive experience in service implementation of these IMC technologies, as well as part of integrations in scaling the performance. So when we do the assessment in terms of monitor the digital experience, how an application is behaving and what is the SLA for it, doing code profiling to see, because the performance can be hidden in anywhere, performance problem. It's not necessary to be at one certain places. So we need to have an assessment at various levels. One at a code profiling, having the code level visibility into application using distributed transaction tracing, and identify the reason for slowness like code errors or slow remote calls or slow queries. Also, it could also boil down to app server performance metrics, like a deep dive performance insight into an application infrastructure. If you see traditionally, you have the JVM, this CLRs, app servers, message queues, and databases. Sometimes it's also possible where the auto-discovered dependencies, wherein the application depends on underlying IT components like network, visualizing, or cloud containers, etc. That also constructs, which generally construct the topology maps, will also be part of the performance issues. So when we analyze all these, we see, as we mentioned, as I had this in the slide, so pretty much everything is getting most of it, 47% of it in the in-memory. So so we have the IMC, then it's really helpful in kind of coming out of these problems, pretty much for the data intensive. And in the move on to the next slide. So basically, I would like to have. Can we move on to the next slide? Yeah. So this slide starts about the performance usage. So for example, there are various use cases which we were dealing with in terms of performance. These are certain possible scenarios which we put it on the right hand side. So basically, the digital transformation, appification, and microservices. You see today, the digital transformation of API-led transformation. If you see, every organization is going for unlocking their functionality and exposing as a service, monetizing that. And there are a lot of APIs which is being exposed both internally and externally. And if you see traditionally, in terms of finance, there are finance APIs like payment gateways, which facilitates B2C, and the volume is very tremendous. So in terms of addressing these kind of voluminous API hits, if for example, if an application designed to support 10 TPS and 1 second response time for these APIs, and the year-on-year growth and its expectation is going to be 100 TPS and 1 second response time, the same application. So we need to kind of have a performance check and the performance assessment, and then to provide the solution accordingly. And these use cases which we had mentioned for digital transformation application for one of the customer, we had these problem wherein the volume is increasing based on certain events. So basically, if you see, it is not traditionally the volume is going to be always. So it's a retail customer where the holiday season there was a peak, and we have been expecting the projection as 16%, but unfortunately it went more than that. So based on this, the problem what we faced is it's an online application where the inventory is very much required. So if you see um, uh, during the holiday season, there is a use case where the retail online will provide delivery to the delivery to the nearby stores. So the problem here was checking the inventory real time to the stores. If it is an online data warehouse, it's very easy. But if it is going to be whoever is ordering a product via online and then checking out, then when you do a checkout, that real-time inventory will be checking on the inventory of that particular store so that it can fulfill that requirement. So the inventory check will go to the retech system, see hey, this product is available. So that's a fraction of millisecond. So we couldn't have the retech system get that inventory at a real-time speed. And what we done is we kind of export these data, inventory data, at a periodic fashion into IMC, and then from there we could able to get it in a fast manner. So there was no performance or page checkout problems, which is taking much time. It's all very good. So this is one of the use cases which we would like to say here. So this IMC technology can be very much helpful in accelerating this performance, avoiding these performance issues and accelerating the speed. And similarly, there are certain use cases which we did for stream analytics for one of the customer where we had IoT sensors for their boilers to check the wear and tear. The data would be seamless as and when this reading comes. There are many. This for one of the oil and gas major in US. So the information what we are getting for this from the API, the Event Hub perspective is more. So basically, we need to apply facts and thresholds to see whether it is having a normal limit or it is it's not good. It's need to be it's a wear and tear is more, or any precaution measures needs to be taken. So this needs to be applied, and then we need to have these based on the assessment of these thresholds. We need to send to the real-time analytics dashboard. So here the problem happened is basically the stream analytics. In the Event Hub, there are many data, and we had Kafka for streaming it, but still we need to kind of stage this aggregation from various sensors to be aggregated and then do a math on it. And this IMC technology we used there, and which was very helpful to kind of to kind of have these data in that IMC as a data grid, and then have a business rules and rule engine applied on it, and then proceed further to Kafka and then stream it to the BI reports from there. So these are certain use cases which IMC technology would be very much helpful, and I just thought of quoting some of them. And there are in the left hand side, if you see the customer for Nissan, so we have been TechM was involved in having this API implementation for connected cars, as you know, as a telematics. So this connected cars for enabling API for telematics for any operations by the driver can be immediately picked up by these data will be sent by a telematics as an JSON XML response back to Event Hub, and then from there the API gateway API will be picking it up and providing the resolution response to that. So for this, if you see this Nissan had connectivity API, this connected car concept for both own as well as the fleet vehicles, and these fleet vehicles have, I mean, once they extend to these fleet vehicles from the own vehicle, there are too many of traffics, and we also went with IMC technologies to kind of contain that. So there are a couple of many use cases which we have been used, especially for State Bank of India, one of the biggest bank in India, having volume more than 2.5 billion transactions as part of IMPS, which is called immediate method of payment gateway. So that is also was helpful. Can you move on to the next slide? So I think we are running out of the time, so I'll just. So Tech Mahindra helps in assessing will help customer to assess whether IMC technology is needed or not for their performance challenges. And there are various stages which we do as part of this assessment, which is articulated here. So we do the value consulting engagement for any enterprise. So basically, we have the span of week four. So week one, we do analyze on the assets. Week two on the IMC technology progression required, whether it is a data grid in memory or it's used as a cache. And also we analyze on the weightage, average, and scoring of multiple options for IMC tools. We do the maturity assessment. We have various tools to score from the application performance aspect as well. Post that, we'll recommend what IMC technology can be fitted with both pros and cons with prototype demo for any of the complex use cases. And finally, we do the report with program charter, how to implement, what would be the timeline, and what could be the tech stack, and even integrates high-level design of these execution plan. So which really helps customer to move on based on this assessment. And this is one of our value consulting Tech Mahindra offers. Would like to share that. Yeah, so pretty much done with it. Terry, back to you.
We'll now go ahead with the questions, Terry. So we've got one question from Naugria. So what value GridGain has over Ignite?
Well, probably the easiest way. We can do it like in comparison, but in a classical way, GridGain is based on Ignite, and GridGain provides a number of enterprise level features, services, support, maintenance for the software. So we have the information on the website. Sure, Terry can share probably the links after that. But again, it's a features, and most of the features in GridGain really coalesce around manageability and kind of enterprise use cases. We also provide managed service offering. We recently announced called GridGain Nebula, that we can run GridGain installations for you. And in terms of features, it's things like the essential application, rolling upgrades, security patches. So that's a very typical model where there is a fully functional open source project that anybody can use, and there is a hardened enterprise version of it in terms of support and services, but as well as features that is commercially available.
Kasturi?
Okay, thank you. Yeah. Okay, thank you. So how does this differentiate from Redis? So that's another question.
I'm probably going to take it myself too. So Redis is a great product, but it's very different. The Redis model is to be a very simplistic product, but and I'm saying that with a positive spin, obviously, not a negative. And it's available for variety of different languages, and really provides you a simple, clean API. But functionally, it's very limited. It doesn't really have strong transactionality. It has no SQL to speak of properly implemented. So its use cases typically coalesce around just a site caching. And that's where the Redis and Memcached originally was used, and it's still used today.
Okay.
So those we typically sometimes can see both in different settings. If there is a need for just a simple cache for web applications like web sessions and whatnot, your checkouts, Redis can definitely work, and a very popular product in this. For kind of a more mature enterprise use cases, for mission critical applications, it's something like GridGain would work much better.
Okay, thank you. There's one more question on what's the difference between a data lake, a data warehouse, and a digital integration hub? So would you or Terry would like to take it?
Yeah, I can take that. Yeah,
Terry.
I'll take this one. This is Terry. Yeah, this is a great point to understand. So especially when you're thinking about digital integration hubs, a data lake is usually a place where historical data is stored. So all operational and transactional data maybe put in your data lake, as well as data from other data sources from the company. And it's kind of a unstructured data storage area. So you have a lot of data there that might be of interest, but it's really typically created for data scientists. So it's somewhere, it's often stored in Hadoop, and then tools like Spark are used to analyze the data kind of offline. A data warehouse is a high performance data storage a collection typically for running long-running analytics. So that's a great place to put data that's been cleaned, it's been prepared, and it's put in there so you can run analytics as quickly as possible. The key difference there is a data lake and a data warehouse are typically more around non-real-time data. With a data warehouse, there's usually an ETL process to get data in there, so there's a delay, and a data lake is kind of everything's thrown in there, but it's not structured very well. A digital integration hub is a high-performance data access layer that can pull data from a data lake. It can pull data from a data warehouse. It can take data from your operational data stores, from data streams, from your SaaS applications, put it all in one place where it's available in a very high-performance data access layer, and many different business applications can access it. So there's a great role for each one of these. The digital integration hub is the one that ties together the data access for driving real-time business processes, though. So it's often used for digital transformations, whereas a data lake is really a data science tool or a kind of a data storage area. And the data warehouse is really about running high performance analytics, but after ETLing data, cleaning it up and structuring it properly and putting it in.
Thank you, Terry. And thanks for the great session, Terry, Nikita, Stalin, and Jay. So I really found it useful. I hope the audience too. So we'll be sharing the recording link as we already said. So you can write to us on email if you have any further queries. We'll be happy to connect after this call. Looking forward. Yeah. Thank you.
Thanks a lot, guys.
Thanks, everyone.
Good night, guys. Thank you.
Thank you. Thanks. Bye.